right, so with 10.7, we're going to use all that good calculator skills with 10.5, or sorry, 10.6. Okay, let me make that go down just a little bit. All right, so let's talk about exponential growth and decay for just a minute. This formula you have seen before. It is quite possible that in place of this y of t, you had an a, and in place of this y sub 0, you might have had a p. Okay, for like amount in the principal amount, it means the same thing. We get a little bit more technical here. The subscript means after how much time. So y sub 0, which we could also call y naught, is the initial amount. Okay, that's how much you start with. All right, which usually that's usually given. Y sub t is the final amount. Basically, it's the amount after t, years or hours or whatever, after t amount of time. The e to the kt part, we know what e is. It's that natural number. It's the rate of growth or decay. Okay? It depends upon if kt is causing e to get bigger or get smaller. All right? That's not going to be that much of a, that's not going to be an issue where we have to determine that. That's not the point of these problems. K is the exponential growth or decay constant. Okay, when we're doing, especially these half-life problems, we have to find K. That's not always going to be given to us. And then T, of course, is time. Okay, I do want to remind you, what is natural log of e to any power? That power. Okay? So if it was just natural log of e, we would just write x. Okay, that's an algebraic step we're going to use here. Okay, the half-life of a radioactive substance is the time it takes for something to be half as radioactive. Okay? Easy way. There are different ways we could fill in this blank, but and that half-life is different for every single substance. So if your half-life for plutonium is something, it's going to be something totally different for something else. Okay, and they're going to give that to you. All right, so let's look at this first example. It says a certain radioactive substance, they don't even tell us what it is, has a half-life of 248 years. That's going to be true throughout this whole problem. This thing's half-life is 248. That didn't change at any point. Okay, so it says how much of a 10-gram sample will remain after 150 years? Okay, so let's kind of guesstimate our answer really quick, and then we'll do it. How much of a 10-gram sample will be left after 248 years? Which would be one half-life. How much of 10 grams will be left after one half-life? 5, right? So how much do we think will be left after only 150 years? Should it be more than 5? Less than 5? More than 5? How much more? I don't know. I mean, we're kind of getting out of, our comfort zone of what we can do in our head. But it's going to be somewhere between 5 and 10 grams. This is a really good way to kind of start the problem so we'll know if our answer is way off. Okay, the first thing we have to do is find K. Okay, so remember our equation. All right, that y sub 0 is the 10 grams, which is kind of off the screen here. This is y sub 0. All right. And we said that there would only be 5 grams left. So look at what I'm doing here. Let me scroll this up just a little bit. I'm going to say 5 grams out of 10. We don't know what K is. And what do you think I should put in place of T? 150 or 248? I'm talking about half-lives right now. 248. So where does the 150 go? It's going to go next. Okay? You have to find K first, and that means you're not going to use all the information to find K. You're only going to use some of the information. Now, we need to solve this equation. We can solve it algebraically and then use our calculator, or we can do y1 and y2 and find the intersection. All right, this is what I meant by we're going to use what we did in 10.6. If we solve this algebraically, the first thing you would want to do is divide by 10. Okay, what is 5 over 10 the same as? It's a half. All right, that's how they get half-life. All right, then what you're going to do is you're going to take natural log of both sides. This is all the same way we solved these last week. So natural log of this, natural log of that. Okay. What happens when you take natural log of e to some power? You're left with the power. This is why we did that whole review thing. Remember, natural log of e to the x is x. And then what's the very last thing we would do to get k by itself? Divide by 248. So we have a little trick. If you're good with remembering, here's the trick to finding k in a half-life problem. Natural log of a half divided by a half-life. Okay, if you don't like the trick, then you got to do this algebra. It wasn't really that hard either way. Okay, so let's go in the home screen and let's type in natural log of a half. Make sure to close the parentheses after the half and then divide by 248. And this is going to give us a decimal, probably a very small number. Okay, here's what I'm going to do next. Because that's all just finding k. We still haven't even answered the question, which is how much of a 10-gram sample will be left after 150 years. I'm going to need to use this number, and I am not going to want to round it. Okay, when I writing down this is okay. But typing in negative 0.003, you are going to lose a lot of accuracy. So we're going to store this in for alpha k. So do you guys remember the store key down here? We've seen this before, but it's been a while. We're going to store, and then we're going to hit alpha, which is this green button, K. You're going to have to help me. I cannot see that well here. Oops. Y'all see the K? Yeah, okay. I cannot see that far. That's sad.
Come on.
So alpha left parenthesis. I should just remember that. Okay, as soon as you press enter, now every time you type K, it will know it's that number until we get to the next problem, and then it'll be different. Okay? All right, that's the first half of this problem. I'm going to put a big line here. Now we're going to actually answer the question. Making a huge deal that this is a two-part problem. How many parts of this problem? 2. You first have to find K, then you answer the question. It says how much of a 10-gram sample will remain. What they're looking for is what is y of t, or y sub t, what is that when t is 150 years? Okay, so let's use the formula. Let's leave that as y sub t since that's what we're looking for. The initial amount, that's still 10. They told us that. We still have e. I'm going to write k, but what is k? It's this decimal, which I have the real accurate decimal in my calculator stored. And then times t, that's times 150. Notice I'm not using 248 anymore. I only use that to find k. All right, now I can just type that in actually right there. I don't even have to do any algebra. I don't have to do y1 and y2. It's actually easier than that because I can just do 10. Remember e is second natural log, and it'll even do the exponent for you. Do alpha k, and it'll know that we mean this decimal. Make sure the times 150 is part of your exponent. If you don't have the updated version, you may have caret symbol here. Make sure that the parentheses don't end until after the 150. And we know our number should be between 5 and 10. If you do something wrong, it's probably going to give you like a really whacked out answer. And this is between 5 and 10, so we can be pretty confident that we did this right. So 6 point, and then this is where we will round. Okay, notice I use the unrounded version of k. If you try to round k and then use that value here, your final answer will not be as accurate as it should be. Okay, so that's how you do a half-life problem. Now we're going to do a bacteria problem, but you're going to see that it's pretty much the same process. The first thing is we have to find K. 2 steps. We're not going to use all the information. We're only going to use some of the information. So they told us that there's an initial count of 500, y sub 0. And we have something about tripling. So if I kind of leave this part blank over here, if I start with 500 and I have tripling, how much should I write over here on the left? 1500. K, I don't know what that is. And how long did it take for the tripling to occur? 3 hours. I'm not using 2000 yet. You're not going to use all the information to find K. You can either do y1 and y2 and find the intersection, or you can solve this out algebraically. If I divide by that 500, and this is when we get into what we did last week, 1500 divided by 500, that's 3. And this was a tripling problem, so that wasn't totally shocking. Do you guys remember algebraically what we do next? Take natural log of both sides. So natural log of 3, and then what's natural log of e to the power of k times 3? K times 3. The ln and the e basically cancel each other out. So what does just k equal? Natural log of 3 divided by 3, which we can use our calculator. We get that decimal, and then immediately I want to go ahead and store it into alpha k. You can store it into any letter you want. I just like using k because it's just the same every time that way. So 0.366, but I'm not going to use 0.366. I'm going to use the more accurate decimal stored into the calculator. Okay, that's the first part. Okay, now we're going to answer the question. So it says, how long? So we're looking for time. What is the time? When the count will be 2000. What is 2000 going to replace? Yt, y sub t. So let's use the formula again. Let's put 2000 and if it tripled in 3 hours, this should be a little bit more than 3 hours. That's a good way to kind of know if we're on the right track. Or it could be a lot more than 3, but it shouldn't be that much more. And go ahead and keep that as t right here. So this is the part where you can do this algebraically. You can divide by 5 and take natural log of both sides, or you could do y1 and y2. Okay, go ahead and try to do this part on your own. I'm going to do this algebraically if you wanted to follow. Okay, I'm getting 3.786. What are the units here? Same as they were before, hours. Okay, just to, if you're good and ready to go on to the homework, you can. Just to really make sure everybody understands, I talked about that whole Y1, Y2. If you're like, I don't know what you mean, let me show you what I mean here. I'm talking about typing in 2000 into Y1, and then typing, this would be an alternative way, or a way you could check your work, however you want to do it. E, alpha K, and then you do need to put in an X here. You know, put an X. That's what we're solving for. Now, if you just did a zoom 6, we're not going to see it. Because remember, I have 2000 into Y1. Now, if you just start zooming out, you'll eventually get there. What may be a little bit better is just to go ahead and say, well, if my Y1 is 2000, then my Y max should be at least 2000, a little bit more than that. And let's see if we can see the intersection. If we can't, we can always zoom out. But I can see it. Second trace, 5, enter, enter, enter. And you can see we get the exact same answer. So it just depends upon what you think is easier, okay?